lot of the things we're doing in algebra right now is just a step up from 8th grade, but it is things that we have just done. We just finished proportions in 8th grade, right? So here we go with proportions in algebra. Isn't that amazing? So a proportion. Do I not have one out there for you? Did you find one? Okay. A proportion is an equation that shows two ratios are equivalent. If a problem situation is proportional, the graph is linear, the line passes through the origin. What is it about a table? It has a what? A what? A what? Constant of proportionality. So when you put y over x, you get for each one, you get the same answer. An equation is in the form of y equals kx. In other words, you have no plus or minus, correct? Everybody okay with that? Yeah? I sure hope so. So you can do this by cross product. Isn't that the name I gave you guys in class? Not butterfly, okay? You can do this by cross product or by the function rule. And here, you just cross this to this and this to this. You're multiplying, and you get a times d over b times is equal to b times c. And we can solve for a, we can solve for d, we can solve for b, we can solve for x, right? So the one thing that you need to do is if you have, if you're comparing two real life things like eye color and hair color, right? Hair color. All right, let's say I had, every time I had 5 with blue eyes, I got blonde hair. Okay, so if I wanted to know how many with blonde hair out of 427, how many would have blue eyes, right? So here's blue eye color, blonde hair color. Okay, so cross multiplied, get 10x is equal to what? What's 427 times 5? What did you get? 2,135. Then I would divide by 10. And x is equal to, let's see, that would move my decimal one time, 213 and a half blue-eyed people, right? Okay, but we couldn't do a half, so what would you say? 213 blonde people, correct? Okay? Because you can't have half a person. Maybe they, what? No, because you couldn't, if this was an exact number, you wouldn't want to say you're going to have 214 because you know for sure you're going to have 213, right? So you could have one that has one blonde eye, one blue eye, and one brown eye, I guess. Yeah. Anyways. Yeah. Use the table below to answer the following questions. Computers to students. So what is the ratio of computers to students? Somebody got it for me? 3 to 10. Computers to students is 3 to 10. Use cross-product method to answer the following. If there are 1,250 students in the school, how many computers would be needed to meet the projected ratio? So you're just doing computers to students. You have 3 to 10 is equal to how many students? 1,250. So that would go on the bottom is equal to C or X, whatever you want to use. Do cross products, and we've got 10x is equal to 1250 times 3. Looks like 3,750. And then I'm going to divide by 10, and when you divide by 10, because you only have 1 0, you move your decimal one place to the left. So x is equal to 375 computers. All right, easy enough? Oh, so glad. Okay. Use the function rule to create a table and answer the following. What is the generalized formula could be used to represent the number of students versus computers? So if the number of students in computers, let's see, if this is computers and this is students, I've got, let's see, what did they give us before? 3 to 10? 3 to 10, so you would do 6 to 20. I mean, you could do whatever increments you wanted to do, right? Or y equals kx, and k is going to be what? What is k? What? What's the number for k? It's slope, yes, but it's also, in this instant, it's your constant of proportionality, right? Which is what? Y equals what? What did they say? Students to computers. So what would you put? Students to computers. That would be your constant of proportionality, right? If you went back, you'd find 3 and 10. Y over x. Remember to find constant of proportionality. It's k equals y over x. That would be your constant of proportionality. Now, constant of proportionality isn't necessarily slope, people. Okay? So there is a difference. Constant of proportionality only works when you have a proportional equation. If I have a table that is not proportional, in other words, you don't have a 0, 0 origin in that table, then you are going to have a y-intercept. Like, let me give you an example, because Miss Moon and I were going over this at length yesterday, trying to come up with something. So anyways, if I had a table like this that was x and y, let's say I had, you know what? I have been recording, okay. Let's say I had, trying to think of something that would work here. Let's say I had 1 and 15 and 2 and 45 and 3 and 60. Okay? What is my k? What is my constant of proportionality? Hold on, that wouldn't be right. 30, 75. 3 and 75. Sorry. 3 and 75. So 40, the change in, right, it would be 75, and here is what? 30, okay, over 1, right? Okay, what about here? That's 30 over 1. Do you get that? Okay. So I have a constant of proportionality, but if I go down 1 here, where am I going to be at? What? 7.5, right? So I have a y-intercept of 7.5. So that's why when you're doing slope or doing constant of proportionality, you have to do it different from a table, because y2 minus y1 over x2 minus x1 is your slope. Okay? It is changing by 30, but your y-intercept here is 7.5, so you have to start with 7.5. This is not a proportional equation here, is it? Because a proportional equation can only be y equals kx. Are you getting confused, John? Because if I take 1 down from here to get to 0, what would my value of y be? If I go down 1, I got to subtract. Oh, I'm sorry. You're right. It would be negative 15, right?
I was confused.
Hold on. This is still wrong, too. Because that would get, no, that'd be all right, because I have a y-intercept of negative 15, right? Okay. So this table is not proportional. Because I don't have a 0, 0. Anyways, we're just gonna do this. Generalize the function formula, okay? They want us to give us a generalized, since students are greater than computers, multiply by a fraction greater than 1. Nobody's ever going to tell you have to do it by proportions or you have to do it by an equation. Just some situations lend itself to be easier done. So when they're asking you for students to computers, since you have a fraction, you're going to have a fraction that's greater than 1, of course, right? So you're going to multiply by a fraction that's greater than 1. When you have when they are asking to do computers versus students, so this is the opposite way. This is computers versus students. Then that computers versus students gives you 3/10, right? So then you would do multiply number of computers is less than students. So you multiply by a fraction that is less than 1. Notice that the ratio is always found in the generalized formula of the proportion. The value is constant of proportionality. These generalized formulas can be used to find the missing values. I don't like to use the generalized formula. For me, it's just simpler to use the proportional setup, and it's what I always go to, it just makes it so much easier for me. I don't know why they teach it that way, except for I guess they figure somebody might need to know. So what they do on their notes is here. What a real estate agent sold a house for $84,000. The agent's commission was $5,040. Okay, it says here what was the commission to selling price ratio in its lowest terms. So if I do commission to sales price, I get $5,040 for an $84,000 house. To me, they want you just to simplify this. So if I simplify this, what am I going to get? And you could do this in your calculator very easily. You could just put 5,040 divided by 84,000, hit math, enter, enter, and it would give you a ratio of 3/50. So there it is in its lowest terms. That is your K. All right? So I'm going to show you 2 different ways you could solve this. One is by cross products. The other one is with the function rule. Okay? Or equation. Remember, a function rule is an equation. Okay? Very simple. What would the commission for a house that sells for $278,000 if the commission to selling price ratio remains the same? So we have a commission to selling price ratio, don't we? And we found that it was 3/50. All right. So we want to know what is our commission. So X over 278,000. We would use cross products on this way. It's 50x is equal to 834,000. You divide both sides by 50, and you get x is equal to 16680. There's never going to be a time where I'm going to tell you you have to use this method unless it's like solving an equation by substitution or solving an equation by elimination. But this is just, you're solving a problem, you'll be able to choose, okay? The other way with the function rule, all right, you're going to substitute your K. This is your K, all right? So y is equal to kx. I get y is equal to 3/50x. So I get y is equal to 3 over 50x times 278,000. And like I said, you'll find that one works better for you. It's easier for you. However it is. The reason that I'm using this is because I'm looking for my commission. If I was looking for my sales price, then this would be turned around. And this, okay, and I would multiply, okay? So my commission is y is equal to 16680. You get the same answer. It's just a different way to skin the cat, as they say. That's an old saying, by the way. Sorry, it's probably not a very graphically nice picture. Skin the deer? Y'all skin, right? Everybody around here skins the deer. Okay? What? You shoot the deer. And then don't you skin the deer? You don't. Who does? You don't know? You just leave it out there dead? Then you shouldn't be hunting.
I don't live in an area where
Oh.
you can go to your grandma's house and hunt.
Okay. All right, let's flip the page. The freshmen at Eagle Nest High School outnumber the sophomores 7-5. So, what are we looking at? We got freshmen to sophomores, and that is 7-5, isn't it? What is the generalized formula that can be used to find the number of sophomores given the number of freshmen? So sophomores to freshmen now we want, right? It says number of sophomores given the number of freshmen. When it says that, it says since sophomores, since they mentioned those sophomores, less, I need a fraction that is, do I need a fraction that's less than 1 or greater than 1? Less than 1 is correct. Okay? So if I was to solve this by a formula, what would my formula be? What is sophomores to freshmen? That's correct. So y is equal to 5 over 7x. That would be your generalized formula. Okay? Because sophomores to freshmen is 5 to 7. Okay? What generalized formula could be used for the number of freshmen given the number of sophomores? Since freshmen are greater, the fraction or ratio needs to be greater than 1. So what am I going to make it? Y is equal to what? I'm comparing freshmen to sophomores. What? 7 over 5x. Okay? It's because freshmen to sophomores is 7 over 5. Okay? So it's a matter of knowing what is coming first. That goes on top. So you could do this if there are 231 freshmen. How many sophomores are in the high school? So I'm going to do it both ways just to give you another taste. I love cross products. Just so easy. I don't think you have to think with cross products, but that's my personal formula. Okay, so we're doing freshman, and they've given us, now, could I use either one with cross products? And would it work? Could I use either formula? Not for cross products, and that's why I like it, okay? Now, watch this. If I do sophomore to freshman, The only thing I have to worry about is that I have the sophomores on top and the freshmen on the bottom. Okay? So I know that sophomore to freshmen, they told me, was 5 to 7. Wasn't it? How many? What did they tell me? 231 freshmen, so that needs to be on the bottom. Okay? That's why I like cross products, because you don't have to think too much. All right? So cross multiply, and I get 7x is equal to 1155. Divide by 7, and I would get x is equal to 165 sophomores. Okay? Now, if I had done freshmen to sophomores, because I got turned around, as long as I keep 7 for freshmen and 5 for sophomores, and they told me it was 231 freshmen, as long as I keep my freshmen on the top line, I'm still going to end up cross products. 7x is equal to 1155. Do you see how that works? So to me, that way just makes sense, because as long as I keep the people straight, you know what I mean? We're good to go. Over here, y equals kx requires me to think. It's asking how many sophomores. So I have to use my sophomores to freshmen, because sophomores are going to be less, correct? Does that make sense? No. Sophomores. I'm going to use y is equal to 5/7 x. Y is equal to 5/7 times, because they gave me the number for freshmen. So, freshmen to sophomores. So I have to use the freshmen. Since sophomores are less, they're asking for sophomores. Since sophomores are less, I have to use the ratio that's less than 1. And to me, I have to think too much for that. Does that make sense to you all? Whereas the other way, I didn't have to worry about what I was doing. It didn't matter. Because if I use the 7/5, I'm going to find out how many freshmen. But they gave me how many freshmen. So I had to use the right ratio for sophomores to freshmen, because sophomores are less. Make sense? Yes, no, maybe so? Okay. All right. We're going to do at least the first problem on your work today together. How do you feel about that? Okay. All right. So you are going to want an extra piece of paper. Okay. 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 I like that I have my little drawer here now. Has everything I need. All right. So, here we go. Practice problems. Define your variables, write an equation, solve the equation, answer the question, or questions being asked. So, I am going to do all my work over here. Number 1, I need to define my variables. So, it tells me the ratio of 2 integers is 9 to 7. Okay, so I've got a ratio that is 9 to 7. 2 integers. Their sum is 1024. Sum is 1024. Find the 2 integers. All right, so what do I have? A larger one and a smaller one, don't I? Okay, how can I represent the larger one? What, 9 what? Ah, so let x equal an integer. Okay, So if I do that, my larger one is going to be represented as 9x. My smaller one is going to be represented as 7x, isn't it? Okay, so if I have 9x and 7x, now I know the total is 1024. I have 9x plus 7x is equal to 1024. What do I got now? 16x is equal to 1024. Now what do I got? Divided by 16. And what do I get? X is equal to what? 64. Is that my answer? No. What do I need to do? Find the two integers. So now I've got 9. I'm going to substitute. I'm going to do 9. I guess that's not a good way to represent it. I should have put this over a little bit. 9 times 64, which is equal to what? 576. And then I have 7 times 64. 448. So I can just do this. Number 1, larger is 576. Smaller is 448. Was that too bad? Not bad at all, is it? Okay, you're going to want to draw a picture on several of these. Let's do another one together. Let's do number 7. How about number 7? See, when it gives you the sides of a triangle, the ratio is 5, 6, 7. That's very similar to yesterday, right? Can't you just put x is, x will be your number of centimeters?
Teachers and students, pardon this interruption. 6th grade teachers or teachers that are in the main building, 6th grade building, we need to hold in classes. Please don't send students out to the restroom or just out of the class, hold in classes until further notice. Thank you.
So here it could mean that x is equal to your a centimeter, right? And you're going to do, whenever you find out what that x represents, then you multiply it. So in other words, on number 2, I probably would draw a triangle, and it says my ratios are 5 to 6 to 7, and I would do, okay, let x equal a centimeter. So this side is 5 times however many centimeters x is. This is 6 times how many centimeters x is. And this is 7 times how many centimeters x is. Does that make sense? Okay. So then it says the total is 231. So total is 234. Sorry. So you should be able to set that up from there, don't you think? Okay. And solve. All right. Number 3, make sure you draw a picture. Remember, how many widths and how many lengths do you have on a rectangle? You have 2 of each, right? So when you draw your picture for number 3, make sure you are noting that you have, because it says the length and width of a rectangle are a ratio of 5 to 4, right? So you have 2 sides that are going to be on 5x and 2 sides that are going to be 4x. Does that make sense to y'all? Okay. All right. The next one should be okay. The next one, you still have 2 sides again. You have a rectangle for number 5. You should have to remember you have 2 widths and 2 lengths. And so you're going to have to make sure you're denoting that when you're getting your total. When you have a perimeter, then you have to account for the fact that you have 2 lengths and 2 widths, all right? Number 6 is just setting up a ratio of 2 integers, and they're telling you what the smaller is. If you set that up like a proportion, you shouldn't have any problems whatsoever. Smaller over larger, and set that up. You should be okay. Number 7, the blueprint dimensions for a newly constructed house are proportional to the house's actual dimensions. On the blueprints, The house foundation measures 75 centimeters in length by 40 centimeters in width. So whenever they give me a picture, I'm going to draw it. So number 7, I'm going to say, I've got a house foundation, and they're telling me it is 75 by 40. And I probably would put this here just to remind myself, I don't know if I need it yet because I don't know what they're asking me. All right. The house's actual foundation measures 15 meters in length. Oh, so this is the blueprint, and this is centimeters, isn't it? Okay, this is the blueprint. The actual, what have they told me about the actual? 15 meters in length. Okay. So, they're saying that what is the foundation's actual width? Actual width. So, if I have 75 centimeters, they're telling me on a blueprint is equal to how much on the actual? 15, right? This is the actual. And this is how I would set this up. You don't have to worry about converting centimeters to meters because they've already told you that 75 centimeters on that picture represents, they're already telling you that's to scale 15 meters. On when you're going out. That's what blueprints are. You will make them much smaller, but whatever the scale is, they're telling you that it's 75 to 15, okay? And here you've got 40 for your width because this is your length and this is your width, and they're wanting to know how much that is, okay? So don't get caught up in that. If you wanted to figure out your actual scale, you could do 75 to 15, and you could simplify that, and you could find out the actual scale they're using on that blueprint. But what we know is that what we need to know is that 75 centimeters for the length of this foundation equals 15. Does that make meters? Does that make sense to you? You don't have to convert it. Okay, because it's a blueprint. They're not saying that's an actual measurement, all right, or conversion. All right, so you just cross multiply and you'll find your answer. You'll find out what the width is. Simple enough? Do you understand that, or are you confused by it? Not confused. Okay, all right. Because some people get caught up in that centimeters to meters thing, and that's why I want to make sure and cover it. All right, that's it. You've got 8 problems. And I've done 1. I've almost done 2 or 3 because the last number 2 is just a matter of doing some math, and number 7 is just a matter of doing some math, and you'll have those done. So that only leaves you 4, 5 to do. Right? Okay. John, did you turn any work in?